Why is system boundary crucial for system modeling? Imagine trying to understand a complex machine without knowing where it begins and ends. That's where the idea of a system boundary comes into play. It's like drawing a line around a part of a machine or process to see what's inside and what's outside. This boundary helps us decide what to include in our model and what to leave out. In system modeling, defining the boundary is essential because it sets the scope of what we are studying. It tells us which parts, processes, and interactions are part of the system. Without this clear line, it's easy to get lost in details that aren't relevant or miss important connections. For example, when modeling a car engine, the boundary might include pistons, valves, and fuel injectors. But it might exclude the transmission or the vehicle's body, even though they are connected. This focus helps us analyze how the engine works without being overwhelmed by everything else. System boundaries also help us understand how the system interacts with its environment. They control what energy, matter, or information can cross into or out of the system. In thermodynamics, for example, the boundary could be a pipe that allows heat or fluid to pass through. Whether it's a permeable or impermeable boundary affects how the system behaves. In mechanical engineering, knowing the boundary helps us see which parts we need to control or maintain. If the boundary includes the electrical system of a robot, then the electrical inputs and outputs are part of what we manage. In system dynamics and control, the boundary is even more important. It helps us identify inputs like disturbances or control signals and outputs like system responses. Knowing the internal states within the boundary allows us to create accurate mathematical models or simulations. This makes it easier to predict how the system will respond to changes and to design effective control strategies. Clear boundaries also improve teamwork. When everyone understands what the system includes, communication becomes smoother. It reduces confusion and helps teams focus on the right parts. It also makes decision-making easier because everyone knows what is inside the scope and what is outside. To sum up, system boundaries are fundamental because they define the limits of what we are studying. They help us distinguish between what's inside and outside, control how energy or information flows, clarify responsibilities, and improve communication. For mechanical engineers working in system dynamics and control, mastering how to set and use boundaries leads to better models, more reliable designs, and smarter solutions. Without clear boundaries, understanding and controlling complex systems would be much harder.